Hi, Reeve students, Miss Dean here, and this video is to show you a really powerful tool. It's called a What I See table. It's super powerful because it takes what you see, which is the most important part of mathematics and problem solving, helps you hang on to what you see so that you can create an algebraic equation to describe a pattern. So What I See tables all have three columns. There's a column for the stage number. There's a column for what it is that you see, and this is where you describe how you see each stage of the pattern. In this case, we're looking at flowers or snowflakes. And in the right-hand column, we record the total number of whatever it is that you're seeing. If we're looking at this pattern, again, it would be flowers and snowflakes. When we're looking at tile stacks, which is the pattern that you'll be considering for your homework and also the one we looked at in class last week, you will be considering this pattern right here, which is built with tiles. So a What I See table for tile stacks has the stage number, what you see in the middle, and number of tiles on the right-hand side. So I have on this slide the way Mason saw the tile stacks pattern. Mason sees adding 4 each time with 2 at the top. And so these right here are Mason's drawings. And I hope you can see that here is stage 1. And in stage 2, there's another row of 4 with 2 tiles on top. So a What I See table for Mason's way of seeing tile stacks would look like this. For stage number 2, there are 2 rows of 4 tiles and 2 tiles on top, making the total number of tiles 10. For stage 3, for stage 1, there's 1 row of 4 tiles and 2 tiles on top. So here it is. In the tile stacks Mason drew, 1 row of 4 tiles and 2 tiles on top. So far in our What I See table, we're using words to be really specific so that we can all see this pattern the way that Mason sees it. And that row of 4 plus the 2 on top makes a total of 8. So in the next row, we're going to take the way Mason sees the pattern and apply it to stage 3. So at this point, maybe we're feeling pretty confident with being able to see this in the way that Mason sees it. So we know that it's 3 rows of 4, and we know we're talking about tiles now. So we can drop the word tile and 2 tiles on top. So we know that and we can replace with the mathematical symbol for addition. So we can do plus, and we can say plus 2 on top. So I hope you can see that the way Mason sees it. 4 rows of 4 and 2 on top. In the next row, we're going to see this the way Mason sees it for stage 4, which is right here. And if there are 4 rows of 4, that's the same thing as saying 4 times 4. So we're feeling even more confident now that we can see this the way Mason sees it. So we can write 4 times 4, and the 2 on top can be plus 2. So let's see. 4 times 4 plus 2 is 18. And here's one that we don't have on the page. Stage 10. Well, if stage 2 has 2 rows of 4 and 2 on top, stage 1 has 1 row of 4 and 2 on top, Stage 3 has 3 rows of 4 and 2 on top. Stage 4 is 4 times 4 plus 2. Stage 10 must be 10 times 4 plus 2, making it 44. So now perhaps we're ready to generalize. Now we're actually ready for a really big one, stage 100, which we probably don't have time to build. And that's really the power of algebra, is to be able to extend patterns into things that are too big for us to build or to imagine without it taking a whole lot of time. So stage 100 would be 100 times 4 plus 2. And I'll let you think for a moment. How many tiles would that be? 402. So now I think we're ready to generalize. So I'm going to add a row to our table. And this row is going to be for stage n. That's a variable that represents any stage of this pattern. If for stage 100, we had 100 times 4 plus 2, and for stage 10, we had 10 times 4 plus 2. I'll give you a moment to think about what the equation might be. N is the stage number, so n times 4 plus 2 should give us the number of tiles. And because this is the way that Mason saw this, I'm going to assign the variable m to the total number of tiles. So now we have an equation that has taken the way that Mason saw this pattern, and from the way he saw it, developed a way of generalizing it so we can know how many tiles are in any stage of the tile stacks pattern. For your homework, you're going to have another way of seeing the tile stacks. And I'm also going to give you a challenge if you choose to take up that challenge. And you'll be able to write a second equation for how to see the total number of tiles in the tile stacks pattern. Thank you for listening.